So today we're going to look at something called standard form. I've written down here 5 numbers, all of which are in something called standard form. These might not look like numbers to you, they might look like calculations to do. And in fact, we can actually work them out if you like. So you should know that 10 times 10 times 10 times 10 times 10 times 10 is 10 to the 6. If you do that, you get a million. So this is 4 times a million. Well, 4 times a million is 4 million. Don't think I need a calculator for that one. Also known, I suppose, as 4 with 6 zeros on the end. Okay, this one here, well, 10 to the power of 5, 10 times 10 times 10 times 10 times 10 is 100,000. And if you times this by 100,000, you're going to get 320,000. Another way of thinking about that was you just move the decimal point 5 places to the right. If you move it just 1 place to the right, it's 32, and then you've still got 4 more places to go, so that's where the 4 zeros have come from. So be careful, the number up here doesn't necessarily tell you how many zeros there are. It does sometimes. Here it tells you there's 6 zeros, but really what it's doing is how many places you've got to move the decimal to the right. Okay, so this is 4. Normally the decimal would be there, wouldn't it? If it's just the number 4, the decimal point is there, 4 point nothing. And then if you move that 6 places to the right, you pick up 6 zeros. I'll do these ones a little bit faster. Move the point 3 places to the right here. This says 9.21 times 10 to the 1,000. Okay, 10 times 10 times 10 is 1,000. So move the point 3 places to the right. That's going to be 9210. It is very common to be incorrect just by 1 position. People don't normally get these wrong with 2 zeros in the wrong place. It's normally just 1 position. It's worth checking once you've written a number down. Have you definitely moved the point, in this case 3 to the right? So initially the point is here. Has it moved 3 to the right? 1, 2, 3. Yes, it has. And I promise you, it's really, really common that, especially when this number's bigger and there might be more decimals, you write down the number of zeros you think it is, but you can easily lose track by 1, and you might have 1 too few zeros or 1 too many zeros, and then going back and putting in the right number of zeros is correct afterwards. It's always easier to write down what you think it is and then check afterwards. Okay, this one here, 5 times 10 to the minus 4. Right, well, think about what negative powers do. They make fractions or decimals, don't they? Let's think about this for a moment. So we know things like 10 cubed is 1,000. We use that one here. You should know 10 squared is 100. 10 to the power 1, or anything to the power 1 is itself. The next one on the list, 3, 2, 1, will be 0. And can you see how each time there's 1 less 10 in the product, isn't there? So this is to get from here to here, I've divided by 10. From here to here, I've divided by 10. And this is still true. The pattern continues. To get to the next one, divide this by 10. That's 1 then. If you don't believe me, try it on a calculator. Absolutely anything to the power 0 is 1. 10 to the power 0 is 1. The next one in the pattern, 3, 2, 1, 0. Well, the next one will be minus 1. And we know that to get the next one, you just divide by 10. Divide this by 10 is 0.1, or 1/10. Okay, and the pattern continues. So if you want to know what it means to have a negative power, it's a decimal. And when you multiply numbers by decimals, they get smaller, don't they? It's smaller than what you started with, or decimals less than 1 anyway. Okay, so this one here then, this is basically saying do 5 times 0.0001. So that must be 0.0005 in that case. Okay, 0.0001 times by 5 is 0.0005. All right. I would suggest, though, that we can use a similar method to what we're doing up here. After a while, we dump the idea that this was, this one here, we dumped the idea that this was 100,000, and we just said move it 5 places to the right. In the same sort of way, I could say move it 5 places, down here, move it 4 places to the left. Make the number smaller by moving the decimal 4 places to the left. Just check that I have done that. For the number 5, the decimal point is there. So number 5 is there. And then have I moved it 4 places? 1, 2, 3, 4. Yeah, definitely have moved 4 places. Okay, this one here then, I'm going to move 6 places to the left. So 0.7, oh no, my bad, 0.0000771. Let's just check that I've got that right. Okay, this is what I mean by write down what you think it could be and then check you got it right afterwards. So 7.71, that's where the decimal point is. Have I moved it 6 places to the left? 1, 2, 3, 4, no, only 5. Okay, so this is not right. I need an extra 0. 1, 2, 3, 4. I had 4 before, so I must do 5 zeros, mustn't I, in there? Okay, let's try that again. 7.71 is there. That was my original number. Move it 6 places to the left. 1, 2, 3, 4, 5, 6. There we go. Okay, so that was not correct. And that one is the one that I needed. I did it slightly deliberately there, but I promise you, most of the time, these mistakes happen and you're not doing them deliberately. It's really, really common to be incorrect just by one position. So it's always best to just write down what you think it is, and then once it's written on the page, you can easily count and check. It's a little bit hard to count and do it all in your head. So what I've been doing here is converting numbers which are in standard form. Okay, the black numbers are in what we call standard form, and the red numbers, well, they're just ordinary numbers, aren't they? So I've switched to ordinary numbers there. At this point, I want to point something out. You only really use standard form in the real world when the numbers are either massive or tiny. So suppose I wanted to describe, for example, the distance from Earth to Pluto in meters or something like that. That is an enormous number, and it seems a bit daft to talk in terms of millions, billions, trillions. After a while it becomes difficult to understand those, and I wonder if you even know what comes after millions, billions, trillions. What English word do we use next? It's probably better just to say, well, I actually don't know how far away Pluto is, but it's a number and then this many zeros on it. Okay, or if you're talking about something really, really tiny, like the length of a virus or something, tiny, tiny things that can only be seen under microscopes. If I said, oh yeah, the length of the virus is 0.0000000, it would be ridiculous. So instead I just sort of say, well, look, this is the number part, and then how many places you've got to move it, how many times smaller do you make it. Okay, so that's what standard form is really for. I wanted to point that out. This all seems a little bit pointless because these numbers aren't very big and they're not very small. I mean, maybe you think 4 million is a big number, but it's hardly unmanageable. The thing is, we have to use fairly manageable numbers whilst we're teaching you this piece of mathematics, because if we just dive straight in with enormous and tiny numbers, it's a little bit hard to actually manage. So I'll be honest with you, the exact questions you'll do today, like these ones here, are a bit pointless in as much as no one would ever really bother using standard form for such small, for such sensible numbers. But you need to use sort of fairly manageable numbers when first learning it. Okay, so black numbers are all in standard form. You should notice then that every single case we've got like some number times by 10, and then there's a power up here. Okay, now this number here is always stuck between 1 and 10. It can be equal to 1. Okay, but it can't be equal to 10. It's going to be strictly less than 10. So it's sort of 9.9999999 is the highest it would ever be. That's what's meant by standard form. When you write a number as something times 10 with a power. Right, so what we have been doing so far then was turning numbers which are already in standard form into ordinary numbers. Perhaps the more useful thing is actually the other way around. So in red here, I've got some ordinary numbers, and I'd like to express those in standard form. What I mean by that is I want to write these as a number between 1 and 10 times by 10 with a power on it. Okay, well, if I turn 26,000 into a number between 1 and 10, the key part here is at the beginning, so that's 2.6. 2.6. And if I had 2.6, how many places do I need to move it? Well, it's 1, 2, 3, 4. That's moved 4 places to the right. 2.6 times 10 to the 4 is the number 26,000 written in standard form. This, as a number between 1 and 10, is just 5. And the number 5, I'd have to move the point 1 2 places to the right. Like I say, a bit pointless. You wouldn't really be doing this in so-called real life. You'd definitely be using standard form in real life. It's very, very important in science. But the point of this really is just to get the idea of how it works, and we're practicing with simple numbers first. Okay, this number read out loud is 70 billion. 70 billion. So this number between 1 and 10 is just 7. If it's just the number 7, how many places do I need to move it? In this case, actually, the same as the number of zeros, isn't it? Because I've got to move the point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. Okay, 70 billion, 7 times 10 to the 10. 0.98. Now this number is less than 1. I still start in the same way. To make this a number between 1 and 10, that's 8. A common mistake people do is 0.8. I do understand why, but it's got to be between 1 and 10, that first thing you write. So 8. How many places have you moved it? Well, the number 8 would have the point there, so you move the point 1, 2, but you've moved it 2 to the left, so that's -2. Notice how for numbers which are less than 1, we're not writing a divide sign here. That's not what a number in standard form is. The whole thing here is the number. It looks like a calculation, and in fact we treated it like a calculation at the beginning. But really that is a number. That is one number in standard form. So it doesn't have divide signs in it. You can have several numbers which are all in standard form and perform divisions if you like, and I'm going to show you that on the calculator in a minute. But the actual number itself is this whole thing here, and it has a times sign in it. Weird, isn't it, to have a number with a times sign in it? Okay, last one then, my last example. Let's turn this into standard form. Well, to turn this number into a number between 1 and 10, that's going to be 4.91. And don't count from here, 4.91 will be there, so that has moved 1, 2, 3, 4 places to the left. So 4.91 times 10 to the -4 is the standard form way of saying 0.000491. You have to take my word for this. It's an enormously useful and worthwhile thing to do in science, but it's a bit tedious when you're first learning it. I'm not going to pretend this is the most exciting topic in the world. Okay, last thing I want to show you is how you type these in on the calculator. Right, so here's an example. You might need to perform all types of arithmetic with numbers that are in standard form. After all, they are just numbers, so you can add numbers together, you can multiply them, you can divide them. This is an example of division, but you could have anything going on, really. Miss Gibbons tomorrow will show you how to deal with calculations like this. In fact, identical to this, without a calculator. She'll show you some little tricks that you might need to help you. However, I'm going to show you on the calculator for the purposes of the lesson today. Now, your calculator has a standard form button, and it's the same one you use for pi, but don't press shift first. Okay, now, it's displayed slightly weirdly on the screen, and I have to keep shunting my calculator up and down, so bear with me. I'm going to type in 9.4 times 10 to the 17. So that's done in the normal way, 9.4. Then I press the standard form button, like so. And it's like little tiny times 10 appears on the screen, and 17. And the 17 looks big, which is a little bit annoying, but really this does say 9.4 times 10 to the 17. It's that exact number there. I can go on, division symbol. Your calculator understands BIDMAS, so it knows that everything to the left of the division symbol here is a number in standard form. It knows that is just one number, and it's not treating it as 17 divided by something that's coming next. The whole thing is the number. Right, next number on here is 4.7 times 10 to the 15. So 4.7 standard form button times 10 to the 15, and it looks kind of strange on the screen because if I can put them side by side, they're just about. What's in my handwriting and what's on the screen doesn't look identical, but they really are the same thing. Okay, equals 200. It's just the number 200. This number in standard form divided by this number in standard form is 200. And it would be a really, really common mistake to just leave it like that. I mean, that is the right answer. That's the right number, isn't it? When you divide those two. Can you see why it might lose a mark? This is not in standard form. Okay, the number 200 is correct, but it's an ordinary number. I need to write this in standard form. So as a number between 1 and 10, that's 2. And I'd have to move the decimal point 2 places. Okay, so 200, 2 times 10 squared, or 2 times 10 to the 2, when written in standard form. So what I think I've covered then, briefly, is you should be able to switch from numbers which are already in standard form to ordinary numbers. And you do that by just doing the calculation. This means move the point 10 places. Sorry, apologies. It means move the point 6 places to the right. This is move the decimal point 5 places to the right. Whereas this one is move the decimal point 6 places to the left. Okay, and my suggestion is, I did this deliberately, but very often I don't do it deliberately, I make genuine mistakes. I would want you to put your best guess down and then check and count. You'll notice that when I wrote that down, I was one too few zeros. I needed an extra zero. It's really common to be wrong by 1. So I summarise that by saying, well, look, what is a standard form number? A number in standard form is something between 1 and 10, but not 10 itself. It could be 9.99999, but it can't be 10 itself. It can be 1, that's okay. Times 10 with a power, never a divide symbol there. Even if you're trying to make little numbers are made by just having a negative power rather than having a divide symbol here. And so you're always thinking, well, okay, let's turn this into a number between 1 and 10, and then how many places does the point move? Finally, I showed you the buttons to press on the calculator. The button on the calculator, oh, that's the wrong one. Didn't do that one. Did this one, didn't we? Okay, and I showed you that the button to press on the calculator for standard form is that one there. Okay, best of luck with these.